Hello, special greetings to you from Scientific Africa. In today's video, we'll be talking about electric circuits. Electric circuits theory is actually very important. Practical is also important. And in Scientific Africa, we are of the opinion that these two entities that must coexist should be given equal attention. Right, and we also believe that if, for instance, you enter this room and everywhere is dark and you want to solve the problem of, chasing darkness away from this room, especially when you want it, then whatever you're going to do is going to boil down to you designing a very simple circuit. If you want to help your people, the people you're living with a very simple design that can help them pump water when there is no water in overhead tank, definitely you're going to end up designing a circuit. So whatever you're thinking about, it will go down to you designing a circuit, and because of that, we are going to give circuit analysis, circuit design, and 90% of what we'll be discussing on this channel will be all about circuits, troubleshooting circuits, building new circuits, and maybe pointing out errors on some certain circuits. And we can't just be saying circuit. In the first place, what is circuit? So electric circuits, we have defined it as the path through which electric current flows. And this is a standard definition. Now, what is electric current? Because we said the path through which electric current flows. The next question becomes, what is electric current? Now, you come down a little bit, you see where we define electric current as the flow rate of electric charge, or the rate of flow of electric charge along a conductor. Definitely on this tutorial, we are not going to define what conductor is. I think we are going to be leaving that as an assignment. Carefully watch this video, the practical aspect of it and the theory aspect of it, and then on a comment section, please kindly help us research and define what conductor is, and possibly give us example. Thank you as you do that. Now, when we talk about circuit, we have two types of circuits. Basically, we can still say we have simple circuit, we have mid-complex circuit, we have complex circuit, but that one is not what we are talking about today. Generically, we are talking about open circuit and we are talking about closed circuits. Now, when you talk about open circuits, you are referring to a setup like this. In a situation whereby that path through which electric current flows is being introduced with a gap or a breach or an opening across the path so that the current cannot completely flow, we call that kind of setup an open circuit. And in a situation whereby you have a complete path through which electric current flows, take for instance, current will flow from this battery. Conventionally, it will go through this way, light up this LED, and we introduced another component called resistor here. Now, what is resistor? Before we understand what resistor is, then we should be able to define electric resistance. What is resistance? Resistance has been defined as the opposition to the flow of charge or current along a conductor. Right. So any material at all that can offer some level of resistance or opposition to the flow of electric current, we refer to them as resistors. Take for instance, in our previous video, we made mention of these as being resistors. Alright, so in the practical aspect of this, we are going to rush this video because I don't want it to be lengthy. We are going to implement these circuits. We have battery here, we have 9-volt battery here, we have toggle switch here for the sake of open circuits. We introduce switch, or the purpose of having our circuit open sometimes is so that we can control our desired outputs. The desired output on this setup is just to light this LED and possibly chase darkness away from an enclosure. Right. So when we introduce switch here, it is now controlled. The output of this LED, the lighting of this LED is now being controlled in the sense that it is only when you close this switch that the LED will light up. So it introduces some level of control, and that is the essence and the beauty of having an open circuit. All right, so let's quickly implement this circuit practically. This is connectors or the conductor. This part you're seeing here, we are going to replace this part with wires or conductors. All right, then we have picked our LED. Okay, we've picked switch, we've picked battery. Look at the LED that we are picking again. So let's get down to the practical. So let's quickly pick our components from the scientific box. So we open it this way. We are picking the battery. We are picking the battery cap. Already we have taken out the breadboard on which we are going to implement the two circuits, the open circuit and the closed circuit. We are picking our switch, press button switch, to enable us to implement, and we are picking up our LED light emitting diode. We are picking up 1K resistor, right? So we are done and we are good to go. So we are done with implementation. You can try it out yourself. So we have introduced a switch. This is an open circuit. So when we press this toggle switch now, the part is complete. It becomes a closed circuit, and the LED will be on not only until this battery dies, but as long as this circuit is closed by means of the switch. So if I press again, it will go off.